Okay, so this is part 2. Let us continue from here. So we stop in this example. So this is part 2. So here we he wants from us to find the angle. First you have to know the vector I, which is 1, negative 2 and negative 2, and for V it will be 6, 3, 2. Find UV first, which is 1 times 6 plus negative 2 times 3 plus negative 2 times 2. Magnitude of U, which is 1 square plus negative 2 square plus negative 2 square, and V, which is 6 square plus 3 square plus 2 square. And we write the formula, which is cosine inverse U times V, magnitude of V times magnitude of U. Theorem: two vectors A and B are orthogonal or perpendicular. Yeah, they are perpendicular if A dot B equals 0, or as they call it they call it orthogonal perpendicular, which is A or vector A dot vector B equals 0, or when the angle is pi over 2. And then the following, so here he wants us to find if vector A and B are orthogonal to each other or not. We just so A dot B, A here 1, 3, negative 5, B 2, 3, 10. So 1 times 2 plus 3 times 3 plus 10 times negative 5. It will be negative 39. So negative 39 doesn't equal 0. So A and vector B are not perpendicular to each other. The dot product also here, it will be for this example, okay, 4 times 2 plus 2 times 3 plus negative 1 times 14, it will be 0. So vector A and vector B are not orthogonal. Okay. I'm sorry. They are orthogonal because A to B is equal 0. Sorry for that. So determine whether vector U and vector V are orthogonal or not. Same thing. It will be here we have 3, negative 2, 1, and here we have 2. So here they are not giving us I, which is 0, 2, okay. So it will be 3 times 0 plus negative 2 times 2 plus 1 times, I write K here, 4 times 4. It will be 0. So U and V and vector V are orthogonal. the dot product, the component, let theta be the angle between 2 and 0 position vector A and vector B. Drop a perpendicular line segment from the terminal point of vector A to the line containing the vector B. Then the base of the triangle has length given by magnitude of vector A times cosine theta, and the component of A along B is written to be comp B equal, for A, equal magnitude of A times cosine theta. And as we know that we have cosine theta equal A dot B over the magnitude of each of them. So for comp B along vector A, we replace cosine by this formula, and we end with A dot B, or I will write it, it's fine, I will write it. So same thing here, I will replace it here. Yeah, I will copy this, copy, and replace it here. But we have magnitude A, so we end up with comp B along vector A. It will be, this will cancel this, so it will be A dot B over magnitude of B. And if we want to find the comp for A along vector B, same thing, but we change the denominator to be the magnitude of A. Projection, so here we have comp for, so comp refers to component, so component B along vector A and component A along vector B. Now we move to projections. If the vector A represents a force, we are often interested in finding a force vector parallel to vector B having the same component along vector B as vector A. So we call this vector the projection of A into B, denoted projection B along vector A. So we end up with projection B along vector A. It will be comp B along vector A times or we didn't have to write times or that, we just write B over magnitude of B, and we end up with project A along vector projection B along vector A. It will be so the comp A, it will be A dot B over the magnitude of B. And we have B over magnitude of B. So we end up with A dot B over B magnitude of B but square, so it will just cancel the square root, because when we find the magnitude of B, it is the square root, and we have square, so they will cancel each other. Times b. And for projection a along vector b, same thing, but we change the denominator. It will be magnitude square of a and a, as we have here. As we have here. Okay, let me okay, give me a second. Okay, we will solve some exercises. We have this exercise, this one, 4a 2 3 and b -1 5. Find the component of a along b and the projection of a into b. Okay, so the component of a along b, so a dot b over the magnitude of a. So we have to find a dot b. It will be 2 times -1 plus 3 times 5, and find the magnitude of a, which is 2 square plus 3 square. For projection, he said a projection a into b, so it will be a dot b over magnitude square of a times a. So same thing, but the magnitude of a we will square it, so it will be 2 square plus 3 square, 4 plus 9, it will be 13. Here it will be square root of 13. So here it will be so it will be 13 over square root of 26. So here I'm sorry, it will be 26. I don't know why. Oh, I'm sorry. So here I think I am right, because he said that the component of a along b, that means a along b, but he in this but he solved it in another he solved it as comp b along a. I don't know why, but in anyways, in the final or midterm, they will write if he want from you to find the comp a along b or b along a. So don't worry about that, because it's just like misunderstanding by some student, that if the question want from him to find comp a or comp b, so that's why. And even in the midterm they write to us what we have to compute, so don't worry about this point. So here it will be square root of 13, and here also projection. Here it will be 13 over 13 times A, which is, yeah, so there is an important point that in the component, the result is a number, and in projection, the result is a vector, because we multiply this by vector A, which is 2i, yeah, it will be like this, 2i plus 3j. So it will be 2i plus 3j. So it is always projection. The answer is vector. The component answer is scalar, which is number. Let us move. The dot product, for example, yeah, for u, for if we have this u, 6i plus 3j plus 2k, and we have v, which is I negative j minus 2k, and they want from us to find the comp v u. So it will be u dot v over magnitude of v. Yeah. So we find u dot v, it will be 6 times 1 plus 3 times negative 2 plus 2 times negative 2. It will be negative 4. Excuse me. Yeah, negative 4, and we find the magnitude of v, which is square root of 1 square plus negative 2 square plus negative 2 square. It will be it will be square root of 9. After that, we find the projection of v along vector u, which is vector u dot vector v over the magnitude squared of v, yeah, times the vector of v. Right? I think I am right. Let me check. Yeah. So same thing, but u dot v, it will be negative 4. So here I will write negative 4 over square root of 9. So here negative 4 square root of 9, and we have power of 2. I mean square root of 9 squared. So power of 2 will cancel with square root, so it will be 9. And we have vector v. We will write it as, we can write it with I if you want. I mean, you can write it I minus 2j minus 2k, and it will be 9i plus 8 over 9j plus 8 over 9k. Thank you.